Welcome to our talk. The ability to store prosodic information is known to be modulated by the use of prosodic contrast in one's first language. We tested to what extent this L1-dependent ability can vary along the level of word goodness of the stimuli. Listeners L1 is known to influence the ability to process and store prosodic information depending on the use of prosodic contrast in one's respective language. For example, French speakers, as opposed to Spanish speakers, show difficulties in storing pseudo-words differing only in the location of stress. Here we examine whether this L1-dependent ability to store prosodic contrast be equally applied to stimuli differing in their word goodness. The term word goodness is used here to describe the level how a pseudo-word sounds like a real word. To this aim, we created stimuli contrasting in F0 that were varied in three word goodness conditions. An existing word with the highest word goodness, and a pseudo-word respecting L1 phonotactics, and pseudo-word violating L1 phonotactics. These two latter are called native pseudo-words and non-native pseudo-words, respectively. We conducted an online adaptive version of sequence recall task that had been used to investigate the effect of language on the ability to store non-native sounds, testing Mandarin Chinese, Tokyo Japanese, and German listeners. These languages and focus differ from each other in the linguistic level at which F0 contrasts are used and in the manner of its use as follows. First, F0 can be used at different linguistic levels. In tone languages such as in Mandarin, each syllable is assigned to one of the four tones and substituting the tone of a syllable changes the meaning of the word or morpheme. A pitch accent language such as Japanese exhibits a limited use of F0 to distinguish words in a manner similar to stress. Finally, in an intonational language such as in German, F0 is primarily used at the intonational level without bearing lexical F0. Second, the richness of the variety of F0 contrasts also changes across languages. German exhibits a richer variety than Japanese because the limited F0 patterns of F0 accents restrict its intonation patterns in Japanese. These different linguistic levels at which F0 contrasts are used and its different manner of use influence the sensitivity to F0 contrast and learning of words contrasting in F0, showing an advantage for L1 listeners of a tone language over others. At the same time, L1 listeners of a tone language are less sensitive to F0 at the intonational level as lexical and intonational F0 compete with each other. No study up to date investigated storing of F0 contrast differing in the word goodness. The word goodness and F0 processing is worth investigating to study whether F0 processing in native, non-native speech and non-speech such as in music without vocal information is on a continuum and to what extent the L1 dependent ability to store prosodic contrast can be transferred on this continuum towards non-speech. This is because F0 is used to describe sounds both in music and language, and it's indispensable in all languages, although its contrast is used at different linguistic levels and different manners. The facility or impedance in storing F0 can occur through the activation of semantic meanings of the stimuli or intonational meanings in this experiment. The comparison between a tone language and an intonational language enables us to examine whether F0 is primarily perceived at the lexical or intonational sentence level in our experiment paradigm and how this influences the memory capacity measured. The comparison between Mandarin and Japanese enables us to examine differences between a tone and accentual language. In this present study, an online adaptive version of a sequence recall task was conducted, testing the following participant groups. For the word condition, minimally paired existing words that contrasted in F0 were selected in Chinese, in Japanese, and German respectively. Since F0 contrast alone in German does not distinguish a word, this disyllabic word imbis meaning snack was selected and varied in its F0 high, low, and low high. For the non-native pseudo-word condition, a pseudo-word numi was selected that followed the phonotactic structure in all three languages in focus. For the non-native pseudo-word condition, a pseudo-word spli was selected that violates the phonotactic structures of three languages in focus. For the segmental condition, a minimal pair of non-words involving a segmental contrast, muku and munu, was constructed. The stimuli were produced using a speech synthesis program, Embola, by defining phonemes using the respective language packages, duration, and F0 places, and pitch were also manipulated afterwards. An online adaptive version of SRT presented sequences of 2 to 9 stimuli, and the task was to reproduce each sequence by typing associated keys 1 and 2 in the correct order. Each condition started with a training session in which they were trained to associate one of the members with key 1 and the other member with key 2. Then they were invited to listen to a single randomly presented token from each set by pressing either key as often as they wished. After they indicated having learned this two-way classification, participants move on to identification tasks. After passing these training sessions, participants enter the experimental sessions. The number of stimuli varied between 2 to 9 according to the participants' previous responses. If the answer was correct, the next trial contained n+1 of stimuli. If incorrect, n-1. Here are our results. The mean achieved length of the last 3 stimuli was extracted for each condition and participant to analyze participants' language and condition-dependent memory capacity of the respective contrast. The full MER model with mean achieved length as dependent measure, language group, and condition as fixed factors and participant as a random factor showed a significant interactions, overall p-values less than 0.001. The between condition analysis showed that in the segmental condition, all language groups did not differ from each other. This condition therefore perfectly served as a control. In the word condition, Mandarin listeners outperformed Japanese, followed by Germans. Also, in the native pseudo-word condition, Mandarin and Japanese did not differ from each other. Further, Mandarin listeners showed larger memory capacity than Germans. Japanese performance was slightly better than that of German listeners. In the non-native pseudo-word condition, only Mandarin and German listeners differ from each other. In the between language analysis, Mandarin listeners show larger memory capacity in the word condition than in the segmental condition, while the other conditions did not differ from each other. German listeners show the opposite tendency, showing larger memory capacity in the segmental condition than in the word condition, and than in the non-native pseudo-word condition. Other conditions did not differ from each other. Japanese listeners did not show any differences between the conditions. To summarize, our study investigated whether the L1-dependent memory capacity to store F0 contrast can be equally transferred to F0 contrast of the stimuli differing in the word goodness. Mandarin listeners generally showed larger memory capacity in storing F0 contrast regardless of the word goodness than Japanese. The least memory capacity was shown by German listeners. The use of lexical F0 contrast alone, regardless of tone or pitch, accent, language, was more advantageous than exhibiting F0 contrast at the intonational level to store F0 contrast of disyllabic stimuli as in this experiment. At the same time, the use of F0 contrast in a tone language was more advantageous than in an accentual language, so that a larger memory capacity for Mandarin listeners were found than for Japanese. A richness of F0 patterns at the international level was not advantageous in this study, so that Germans did not outperform Mandarin nor Japanese. Besides the 3 F0 conditions, the segment condition perfectly served as a control while showing no differences between the language groups. Mandarin listeners seems to be sensitive to F0 in general, thanks to their L1 experience. The patterns of memory capacity shown in each group along the word goodness were different. Mandarin listeners showed the largest memory capacity for existing words, followed by that for the both pseudo-word conditions, which did not differ from each other. This suggests that F0 is an essential lexical entity that is processed together with segmental information in this group. The lexical advantage shown in this group suggests that in the word condition they accessed these minimally paired stimuli word and activated both of them. In this sense, the memory tested in this condition can be also regarded as semantic memory. Further, the violence of the native phonotactic structure did not impede their F0 processing, meaning that it just mattered whether the stimuli were words or pseudo-words. They were still able to concentrate on F0 contrast without being violated by the non-native phonotactic structures. Their general sensitivity to F0 may be the reason for this result. On the contrary, our German listeners show that lower the word goodness was, the larger became memory capacity, suggesting that segmental processing outweighed F0 processing because the former impeded the latter. This claim further supports that the finding that their memory capacity in the segmental condition was higher than in other conditions. Why was their F0 memory impeded by the segmental processing? We propose that the German listeners may have activated more intonational meanings while activating the stimuli of higher word goodness, and this made the F0 storing process more difficult. How about the Japanese listeners? Interestingly, they showed any significant differences between neither conditions. The results indicate that differently from our Mandarin and German listeners, they seem not to have accessed semantic meaning, either intonational meanings. One of the reasons why they might have not accessed semantic meanings surely lies in experimental paradigm. They had to memorize F0 contrast under time pressure without being forced to distinguish semantic meanings. Japanese listeners had been shown to be slower and less accurate in activating minimally paired words contrasting in F0 than Mandarin listeners in previous studies. Further, our Japanese listeners did not show any impedance by the violence of native phonotactic structures. The comparison between the German and Japanese listeners' performance again supports the claim that German listeners may have activated intonational meanings in processing F0 on the stimuli with higher word goodness, while Japanese didn't. In summary, we claim that the data indicate the following. Mandarin may have activated lexical meanings, while German's intonational ones, but Japanese remained inactivated in neither meanings. With respect to storing F0 contrasts of disyllabic stimuli, our results, together with our previous studies, Asano and Mitterer 2019, show that speech processing in native, non-native speech and processing of non-linguistic speech may not be on a continuum. The word goodness matter differently according to how F0 is used in listeners L1. For Mandarin listeners, the word goodness mattered in a sense that higher word goodness was more advantageous in storing F0 contrast because it aided lexical access. Although the result in linguistic and non-linguistic pitch condition were at the same level, the underlying mechanism may be different. In the non-linguistic pitch condition, they only relied on their general sensitivity to F0 that had been developed through their L1 experience with F0. Prior experience with the tone system is known to be advantageous in differentiating F0 not only in language but also in music. The application of their general sensitivity to F0 was also the case in both pseudo-word conditions. However, they somehow had to process segmental information at the same time, so their memory capacity decreased compared to that in the word and non-linguistic pitch conditions. For German listeners, the word goodness also mattered in sense that higher word goodness accelerated the activation of intonational meanings, which did not aid them to store F0 contrast effectively, but rather impede it. For this group, a non-linguistic pitch processing in a sense of storing disyllabic stimuli contrasting in F0 does not appear definable on a continuum from native, non-native speech to non-speech. Assumably, the underlying mechanism in the linguistic and non-linguistic pitch storage in this group may be different, but this proposal cannot be further examined in this study, for which future research is needed. For Japanese listeners, the word goodness did not influence their performance, suggesting that they may have separated segmental and F0 processing from each other, and processing F0 at a more abstract level regardless of F0 of speech or non-speech. These are our conclusions. Higher word goodness was more advantageous for Mandarin listeners, aiding their lexical access. Higher word goodness was disadvantageous for German listeners because of activated intonational meanings. Word goodness did not matter for Japanese listeners processing F0 at a more abstract level, and separating it from lexical and intonational meaning. And we thank the English department at the University of Tübingen for testing participants. Thank you very much.